All right. Welcome everyone to the Next.js, Firebase, and Node.js workshop. Otherwise, I'm going to call it the Backend Infrastructure workshop. I think, as I asked earlier, I don't think anyone was in the React workshop, but in our React workshop, we built a to-do web app, basically just to keep track of things to do. We built the front end in React and JavaScript. But we didn't really go into storing data, making it usable across different clients, right? Just for everyone to note, the front end in React is on a website. I can show it here. I think I have it open. Uh, this is what we have so far. It's a website. If I hosted this and somewhere, you'll be able to access this on your end, and I'll be accessing it my end. But we didn't really make a way of, oh, sorry. We did not really make a way of us to store the data from our users, from each of you, or making it usable across different clients, right? So how would one do that for a project that you are going to make? Well, we have this one system. It's called the client server system or infrastructure. Basically, the main idea of a client server system is that there are multiple clients that can access one server. They're all connected via the internet here, if you see in this diagram. And the clients can be anything. The clients can be your smartphone, your laptop, a PC, a tablet, a TV if you have one, smart TVs and all like that. They can all access the same thing from the server. If you think my biggest example is going to be Instagram. You can use Instagram, the mobile app. You can definitely use Instagram, the website. You can use Instagram on your laptop, whatever it is. They all access the same servers. You see the same images, the same posts. You can log into your same accounts, right? And what does the server do? Well, basically, the server does all of the data processing. For example, when you log in to your website or to Instagram, in this example, you are sending a request to the server. You're basically asking the server to log on, and the server will decide if you are the person you say you are with your ID, with your password, and it will return to you some kind of response. Right? So, how does this requesting system work? Well, basically, we call this the REST API, and there's four parts of it that's available, right? We're going to talk here about I'm going to talk about the HTTP side here. There will be get, which is basically just getting data from the server. If you refresh your Instagram feed page, you'll get new images, new posts. That will be get, right? You will be get post. Post is creating data in the server. When you upload an image to Instagram, you will be posting to their Instagram to the server, and then there will be delete. We just remove data in the server. I think that's pretty self-explanatory. If you remove a post from your feed, um, that's deleting it directly from the server. And then the last one is put. Put is basically updating a data in the server. If you upload an image into Instagram, and then you want to change the caption, for example. That would be an example of a put REST API. Basically, you're asking the server, hey, I want to update the data that I've already created. The response from the server will be in form of JSON usually, and the responses from the server is very broad. It could be just an OK signal from the server. It could be data. For example, if you've made a new account, the server might send your client your phone details about your information. Okay, we created this account with this ID at this time. And basically, there's lots of different responses. We can see lots of some of the responses here. I'm not going to list all of them. There's so many of them, but you might find some of these familiar. Um, the first one is 200 okay, right? Basically, request was successful. Usually, when there's not that much else to say, for example, you're just testing if the server's on, for example, for the first time. The server will respond with the hard okay, and you know you're connected to the server. If you're updating or creating a server, for example, the server might return 201 created. Basically, a new resource was successfully created, whatever it is. 400 bad requests. The 400 bad requests is basically just invalid request. Think of it if you are trying to upload an image to Instagram. Again, I'm going to use Instagram a lot as an example here. Um, if you're going to upload an image to Instagram, for example, but you do not provide an image, the image failed to upload for some reason, or if for some reason the request just didn't have the image, it will return a 400 bad request because it says, "Hey, I need the picture to finish whatever I'm trying to do." 401 unauthorized. In short, 401 unauthorized is if your endpoint, that is like what the function we're trying to do, requires some sort of authorization, either a login or a user ID, email, whatever it is, and you do not provide it, right? Similar to 403 forbidden, 403 forbidden basically means that you don't have access to it. The difference between unauthorized, 401 unauthorized, and 403 forbidden is that 401 unauthorized is you're just not authorized at all. But in 403 forbidden, you might be logged in, but you don't have access to the resource that you're requesting. I think this is the most famous one, 404 not found. 404 not found basically just means whatever you're requesting, it does not exist, right? If you're trying to access a deleted post, for example, well, it's not found anymore, right? And the last one is the internal server error. The server error is basically just a function error. Something in a server broke, your request wasn't handled properly, and it just returns a 500. Something went wrong. We don't know what it is. You could give more details if you want to, but that's not necessary. It's generic. All right. So the next part of this backend systems is, at least for our purposes, Node.js. So what is Node.js? Basically, Node.js is just a runtime environment that allows JavaScript to run outside of the browser. For our React workshop, part of setting React up is that we need Node. And this time we're using pure Node and no React, at least for the backend systems. So why do we use Node as the backend system? Well, Node is asynchronous, it's event driven, and it's built on the JavaScript engine. Asynchronous just means that it's non-blocking. If, for example, I make a request and somebody else makes a request, um, it waits for the request to finish before doing anything else. So it doesn't block, it's sequential. It's also event driven. So the server's always running, but it's not always running the functions. It's only running the things that it's running when I ask it to. And so for that reason, Node.js is used for backend development, APIs, real-time applications. Again, some of Node.js features, they include it's non-blocking, right? It can handle multiple requests asynchronously. It is single-threaded, so it uses an event loop for concurrency. It's a module system, so you can add lots of modules to it if you need to. There's so many libraries that you can use for the backend systems, and it's cross-platform. It runs on Windows, Mac OS, Linux. So whatever your development environment is, you're good. Node.js is a really nice and simple way to go. And the other part of the equation is Express.js. So basically, Express.js is just a React framework for building web applications. It provides features like server-side rendering, static site generation, and API routes. And for today, we're going to use the API routes. Express.js has lots of file-based routing. So there are pages created inside pages are created inside other pages or directory. So there's a whole structure that determines the routes. You can use it also to make websites. You can use it for client-side rendering or server-side rendering. It allows updates in static pages. And for all purposes, we can use it for API routes. It's a backend functionality that that allows us to do pages like this. We'll see later on. And for our services, we can also use okay, single threaded. So I have a question here. Single threaded. So how do they scale servers? So oh, sorry, give me a second. Uh, go back to the slides. So it can handle multiple requests asynchronously. So it's for each request, I believe, is single threaded. So it it doesn't get auto sequenced. For some languages, it might get auto sequence. Do not quote me on that. I think. Um, but yeah, I believe this is single threaded for each users. Okay, I'll have to get back onto you on that one. Okay, and so for our infrastructure, we're gonna use Firebase Firestore, but Firebase gives you more than just Firebase and Firestore. But again, what is Firebase, Firestore? What is all that? Well, Firebase is basically just a backend as a service by Google. Um, it provides a lot of services. We'll see in the next slide, and it's designed to be your all-in-one stop. So Firebase is interesting because Firebase is supposed to eliminate this whole server infrastructure. The idea of Firebase is that you're able to have one Firebase instance and that your app can just can work with Firebase and not need a server. So Firebase was actually designed to eliminate the need to make all of these Node.js, Express.js servers. But you can obviously use it in your backend servers. So what are your Firebase usage? Well, first of all, there's Firebase authentication. You can log in with user email, with user emails, Google, Facebook. I believe they also do like Game Center if you're making games. And they handle all the authentication, including storing your credentials securely in a server, making tokens for you. Cloud Firestore is our NoSQL real-time database, similar to MongoDB. If anyone's ever used the MongoDB, it's the Firebase equivalent of that. They also have real-time databases. It's another database from Firebase that's syncs in real time. So if you need to have the same amount as the same data and different clients, for example, you can use real-time database. Firebase storage. Firebase storage stores bigger files like images and videos. I've used this one personally, and it works really good. The next one is Firebase hosting. You can host servers, host websites on Firebase. Um, my personal website is actually hosted on Firebase, so and it's pretty good. The next one is Firebase Cloud Functions. Basically, it's serverless functions for backend logic. It's their take on if you want to make a backend server. And I believe the last one is the Firebase Cloud Messaging. So Firebase Cloud Messaging's main focus is sending push notifications to devices when there are changes in the server, say your database or anything else that you want to connect to it. So Firebase comes with Firebase Admin. So Firebase Admin is used for server-side Firebase operations, authentications, Firestore management. It requires you to have admin credentials, and it's typically used in Node.js servers. So I'm going to show you Firebase in the main website. Here I'm logged into my school email. I have my own emails. If I go to the console here, I believe it should open. So I have one for today's demo. But if you've ever come to this website, come to Firebase for the first time and you log in with your Google email, you can come here to your Firebase project, create a Firebase project, name it, let's say test for this purpose. It will give you a random name, and because this is a school email, this is your Google Cloud organization, you can obviously use your own personal email. You can read this yourself, but basically, do you want testing from Google? Yes or no? And then it will generate my Firebase here. A second to generate the Firebase instance. And so once you make your instance, you can see you can implement it in your Apple apps if you work with Swift, iOS development, Android if you do with Java and Kotlin or React Native. You can also do it with web, right? This is if you want to make a serverless infrastructure, right? And you can see here in your build, these are all of the other functions that Firebase can help you with. Authentication, Firestore database. And it's really simple. You just go to, I want to make a Firestore database, for example. Let's see if it will load. And I say, okay, I want to make a database in the United States because I'm here. You can start in test mode or production mode. Basically, this is just your rules on how people can access your database. And you just create and yep, and it will just make you your own database, right? Now, if we want to do Firebase admin, like we are here today, for example, we're just gonna go here to the settings, project settings. You want to go to your service accounts, and basically, I can generate a new private key, right? It will, yeah. So your private key will give access to any project to your database, basically. Even if you lock it, even if you close all access to it, any instances that has the private key will have access to your database. So it's very recommended to keep your keys secure and not share with people because if it leaks, your database is basically wide open. And it will give you a JSON file there. They do come with pricing. Um, for me, the free tier is enough. But if let's say you use your database a lot, you can pay up to a certain amount, and basically you get more storage, more bandwidth, more uploads, more downloads, and everything like that. What would you get? Yes. So for today's demo, I've made this simple Firebase instance with our task later on. We'll see. But yeah, so this is basically just the same thing with Firestore database. Okay. And I've an additional tool to help you with your backend journey, when I say so, is Postman. So Postman is an API tester platform. You can test any API, any queries, and any payloads. You can also make accounts. You can make your API test shareable. It's a static sites for free, but it is for free. Yes. Um, and you can also visualize your data returns, your API hits, and I'm going to show you here. This is we're going to use this later on, but for now, this is Postman. All right, let's get to the example then. Okay, any questions so far? I feel like I was talking a little bit too fast, but in the case that everything's good, we can go to the examples. All right. So this is our website. Please compile. Okay, so this is the website that we made. Uh, that basically we made last time is this part, right? We made uh, again as I showed earlier, this very simple to-do list. You can type here, you can add, and it before we added the backend functions, it will store your data locally. But now we've added three new functions. First of all, get task, right? If it's overwhelming, if you don't know JavaScript, it's the same thing as this, basically. It is exactly the same thing as this. This and this is the same thing. Just the keyword async here means that there is an await function inside. And what await does is basically we're waiting until the function finishes running, right? In this case, it's a request. So as soon as we get the request back, we will continue with the next line. In general, you can use await for anything, but await basically just blocks you from doing anything else while you wait for the function to finish. Here we can see the API URL, right? Our API URL is this one. And basically, our API URL is the destination where we're asking from, right? Your server, and slash task is the path. Well, slash task is the path that we're asking from, right? You can also see it here. This is just getting. You can see get. Here we have a post where we're adding task, right? Or we're creating a new task. You can see delete here. Delete task with an ID, and we can put an update here. But yeah, and Axios is just a library that I personally like to use. You can use Fetch API. If you want to know more about that, I can talk about that later at the end. But essentially, you just download add the Axios library, and the Axios is basically just a requester. For the most part, it's just asking the server and storing the data locally. Again, this is what we talked about last time, so I don't really want to get too much into it, don't waste too much time. But if you have any questions, I can talk about it later. And where is it requesting to, right? Where is localhost 8989? Obviously, localhost 8989 is currently on my laptop. If you host it somewhere, say AWS, or I use Render for free as well, this will be wherever your address is, right? So if we see here, this is my current server. It looks a little bit overwhelming, but it's very simple. So to make one, I think let's try that. Right? If I want to make a new server, for example, I can, yes, just demo. I can do this. I will go to my terminal, right? I will make a directory. Let's say test server, right? I can go into test server here. Where's the function? Where's the folder? Oh, ooh, sorry, I made a mistake. Sorry again. So I will make a folder where I will store all of my server stuff. I will go into it. First, I will do I will initiate a node, right? Yes, the name will be a test server version 1. You can add a description, an entry point. Basically, it will start a node, a node environment for me, right? And since we're using Express.js for to help us, we're gonna do npm. Let's do this. Let's see here. I will install Express. It will run all the Express magic. And then when you open this, you can do server.js, right? Or whatever you want to call your entry point. You're first gonna import Express.js, which is done this way. Right? Again, this is a variable, so you can name it anything you want. And then I will be Express, right? And I will start the server by doing this at a port. I'll do port 8888. and give it a function to run when it loads. I'll say, hi, the server is on, right? And if I did this correctly, I can run it with node server.js. Again, the second part is whatever you name your server file. You can name it index, you can name it your own name if you want to, I guess. And if I run it, hey, the server is on, right? So it's very simple to start. You need this part and your server's basically on. All right, let's go back to demos. All right. It's the same thing here, all the way down here, right? I have a port that I'm listening to, and I say, hey, server's running on this port. And if I do node server.js, I will see that my port should be on. Yep. So my server is on and running at port 8989. All right. So what are the sum functions here that we have inside the server, right? Again, we have get tasks. We have post, right? Create a new task. We have put, which is update a task, and delete a task, right? All right, now I want to talk a little bit about the Firebase side on the server. We are starting with our initialization of Firebase. So again, admin, we just need to do npm. So we would want to install Firebase admin, which I already did. But yeah, it will tell you like something like this. And then we will be running. We have the key. I guess I can show you the key. Yeah. Usually you do not want to show people the key because this is all your secrets. Basically, each of this is imagine it as your password that accesses directly to your Firebase, right? So you want to keep this as secret as possible. But for me, it's fine. I'm going to delete this after this. So not to worry. And just basically initialize it, pass the credentials over here. And this is importing from the key. And basically, we already have a handle of our Firebase, right? And from Firebase, the service that we want to use is Firestore. So we just call Firestore and give a handle to it, which is DB. All right. So let's start with get task here. So the idea behind get task is that we want to look into the database and we want to get all of the tasks that is in one collection. If you see here, a collection is this, right? I can start a new collection if I want to, people, for example. And I will be like, I can generate a new ID here, name, maybe, and this will be a whole collection, right? So if you want to store lots of people's information, you want to put it in like a people collection. But for today, we want to get everything that is inside task, right? Task collection. So how do we do that? Actually, let me move this to be closer to. Okay, this one. Yes. So define the task, the collection name, tasks, right? You can also type it directly here if you want to. So you want to say in the database, open the collection, and then whatever collection you want, and get all, right? What this will return to you is a snapshot. Snapshot is a Firebase type, right? And the snapshot basically contains all of the results of your query. If you think about if you ever work with SQL database or any databases at all, when you run a command, it will return to you whatever it found, right? This you can see the docs. Docs is basically just a singular information, a document, and basically we're just mapping it and filtering out, getting each individual document from the collection of snapshots. And basically, we're just returning this part, res. Res is your response. Again, rec is request response. You're basically just sending the list of documents as a response, right? Same thing with creating a new task, right? This is the other way around. So again, this is creating a task, and then to connect to talking to the database, you just connect to the database. Say I want to open this collection and add, right? Very straightforward, and it will give you either an OK or an error. In the case that it's an error, you go to the catch function here. I believe everyone should be familiar with try catch. And it will basically just send, hey, I don't know what happened. There's an error, 500, right? We see the error code again. For specific documents, right? So let's say updating and deleting tasks, right? We get the ID from the request, right? If we say, if you start with, um, what is this? So not that's not semicolon. With this symbol and anything after that, it will be a variable, right? It will be a param right here. This is how we're accessing the variable here. And we're basically saying, hey, database, open the collection that we've already opened, get a specific document with this ID, and then basically get it, right? We want to get it. And if it responds, so the response will be in task. We can check if the document exists or not. And if it doesn't exist, return. Obviously, we don't know what they're asking for. Or if they found it, we're gonna do this one, update. Very simple. Again, it's a document. Just do update, and then all of the fields that uh, all of the fields that we're updating, and then basically tell send back a response. Task is updated, right? Same here with delete, but instead of updating, it just deletes it, right? Right. So how do we visualize this? Oh no. Okay, sorry. My can go back to here. Move this. Right. And this is Postman again. I want to make sure I run the server. Nope. Okay, you can see the server's online. And how does this work? Basically, let's just try asking for the server for tasks, right? Sending requests, we got a status 200 okay. So the server, we successfully talked to the server. The server recognized our request, and we basically just get an empty array. Well, why is that? Well, if you see in our database, there's really nothing here, right? If I try to make something here, I don't think this will work because it's typed. But I can try again, and it will give me whatever I just made, right? You can see that and this are the same. Let's delete that. Right. So what's nice about this is I can save this if I want to. I can make it a new collection, and be like, hey, this is testing the server. I guess I can save it to my own collection if I want to. And there you go, it's reviewable and I can share it with you if we're working with the same server. Let's see, did I make this? I did not. Another function, like we can also try to um, make a new request to the server, create task, right? That's good to create, and basically we can see, okay, text, and well, that's it. So text will be, hi, this is a task, right? And I can send it to the server. Let's see if the server requested it. And the server said, oh, okay, we get okay. And basically it returned this, right? And we can see here in the database, yep, this is connecting directly to the database, right? We can also see it from our website. Oh, sorry. There you go. Right? If I refresh this, it will fetch from the server and say, hey, this is task. Right? You can see here, completed false, created at time and task. Right? If I cross it out, for example, if I update this, should be able to see it. Yep, now completed is now true. Um, if I delete this, for example, and then I check the database again, up, there's no more task, right? Yeah, so that's basically the basics of Node.js, Express.js, and Firebase for the purposes of this. Um, I can talk more about it. I just want to see if anyone else have any questions right now um, in the Zoom. I don't know if there's any questions. Oh, Colin, yes, thank you. Um, it is NoSQL, yes. So Firestore is NoSQL. So if you want to find a SQL server, you're out of not Firebase is not for you, but you can make complex queries. Try to open the project maybe. Yes, this will be recorded as this will be posted as recording. Yes. I'll also try to put this on GitHub maybe. I tried to do it with the one before, but it didn't work. But I'll try to get this on GitHub so you can see an example. I'll also try to make more examples if I can. But yes, this is NoSQL. It will be on the YouTube, and I'll set an announcement for if it's already uploaded. Sorry. So you can see this one is requesting it based on the ID. You can also get all, for example, like this one. I think you can get also takes an argument. You see here with the argument. Um, yeah, so it executes a query. If I do query, um, query, yeah, query, right? And then I give my arguments here, where name goes to like, sorry, where the field is equal to, and then I do like my name, right? I pass it here. Um, it will run it based on the query. So it will return to you based on this query. So you can make as complex query as possible. It's just, I guess, a little bit more difficult than SQL. But it is a nice way of, if you don't know SQL at all, it is a programmatical way of making a database. Let's query, I guess. Any other questions? So yeah, so it does. So what's nice about this is that Firebase is mostly free. It does come at a cost when you get more and more users. But I think for school projects, at least, I use it for some of my projects. It's not too heavy in the sense of it. You don't really need to pay, and if you even forget about it and you do pay, it's used to like very cheap. It's a very cheap service for what it does. I can show you um, my personal and yeah, you can see I use it a lot. I use it for lots of different projects. Some of these are just databases, some of it is actual hosting. Um, this one in particular is one of my bigger projects. I can show what it looks like. I do authentication, right? So there is a user that has a user ID. Again, I cannot even see the password here if I want to, so it's very secure. It is hosted. Yeah, I can open this, I guess, and open the website for an event. Um, you can see images. I have lots of different images here, lots of different um, folders. Oh, sorry. Um, Firestore also. Um, Complex database if I want to. Um, yeah, this is serverless infrastructure, so it's directly accessing the servers. Um, yeah, it's a very good way of learning databases if you haven't making your own projects. And again, you can host it for free. The only caveat is it doesn't come with the custom name, so you do need your own domain if you want to. But if you are okay with just this as a website, you can share this link, and you guys can even open this if you want to. Yeah, it's a very robust system. I think some people are also yeah. So it's pay what you like. Sorry, pay what you use, rather than being a subscription, which is nice. Um, in my as you can see, like I've used it a lot, um, and I haven't paid at all for anything. This is with like 200 people using it at some point, March 31st, I think. And it at its peak it was only using like 1.8 megabytes, and you get like 5 gigabytes. So you're usually good unless you want to make like a really big app from the start. And even then, like it's still a pretty good service. Yeah. It's also nice because you don't really need to worry about um, figuring out each database individually. Like if I have a database and an authentication server and image storage, for example, there and it's catered, it might be harder for you to keep track of instead of just this. It's at Firebase, you're done. It's an instance, right? Yeah. Is there any other questions? If not, I might stop recording and feel free to talk to me about this. I can show you other projects where I use this. I guess not. All right, I'm gonna stop the recording.